The Wave Carpet, Development of a Submerged Pressure Differential Wave Energy Converter by Lehmann, Elandt, Shakeri and Alam. A very long title for a pretty cool concept. Let's talk about it. Before I start, quick disclaimer, unless otherwise specified, all the information in this video comes from this article, and I will leave a link to all my sources in the description below, as well as showing them on screen when they're relevant. In 2014, it was found that 3 million people lived within 200 kilometers of the world's coastlines. This number is expected to double by 2025. On top of that, the world wave power potential is approximately 29,500 terawatt-hours per year. Both of these factors make wave energy a very viable prospect for commercialization. So why hasn't this happened yet? First of all, wave power systems can experience a lot of damage due to harsh oceanic conditions, leading to huge maintenance costs, and they can be a danger to sea life. There can also be jurisdictional issues, as international waters that can often be used for these systems aren't under any laws. The main engineering issue is that it's difficult to design a device that can harness the energy of infrequent and nonlinear waves. Where does the wave carpet come into all of this? The wave carpet, as shown in this 3D rendering, is a new device designed to harness wave energy. It was inspired by the attenuation of surface waves when passing over a muddy seafloor, which is a process in which the waves lose intensity and amplitude due to strong interaction processes with the mud that transfer energy away from the waves. As you can see in this photo, the muddy seafloor on the right has much less wave breaking than the rigid seafloor on the left, showing that the wave energy coming in has been reduced by the mud. The wave carpet is made up of an absorber carpet, connections, a power takeoff system, and a mooring system. The absorber carpet passes energy absorbed from the waves to the connections, which in turn transfer this energy to the power takeoff units. These then convert the kinetic energy of the movement of the carpet into hydraulic energy. The mooring system is what ties the carpet to the seabed or to the wave tank in the case of experimentation. Let's discuss hydraulic energy for a moment, as this is what the wave carpet ends up getting from the movement of the waves. Hydraulic power systems can have linear motors, which consist of a piston and an outer casing. The piston transfers kinetic energy from a pressurized fluid to a motor or generator. In the wave carpet, this process happens in the power takeoff units by taking energy from the surface waves and transferring it to linear springs, which drive generators to extract the energy and then return the carpet to its equilibrium position. So what are the advantages of the wave carpet? Well, the wave carpet can supposedly absorb all the energy of incident waves. It is also suited to real oceanic conditions, where waves have a wide range of different frequencies. It's omnidirectional, so it can absorb the energy of waves from all directions, and it's completely underwater, so there's little danger posed to boats and no visual pollution. There is also apparently no risk of entanglement to sea life. A major advantage of the wave carpet is that it works even better under stormy conditions, meaning that it may be less damaged over time and maintenance costs will be lower. The water column above the carpet acts as a buffer to strong storm surges, which means it can be used as safe havens for boats in open seas, or it can protect coasts and harbours from storm waves. The wave carpet was tested in a wave tank with a motor-powered wave maker at one end to stimulate different oceanic conditions. The wave frequency and the wave height were varied to provide a range of different wave energies and a range of ratios of wavelength to carpet length. The stiffness of the springs and the pump height were also varied. This was all done in order to investigate the absorption and conversion efficiency for different conditions and different device parameters. The water level was held constant throughout to ensure a fair test. As a result of experimentation, it was found that the peak conversion efficiency was 42.3%, and the peak absorption efficiency was 99.33%. The absorption efficiency is clearly excellent, but conversion efficiency could be improved. These results were used to build a working prototype. A different article provided more advantages of the wave carpet, but also provided disadvantages which the original paper lacked. This article claimed that the wave carpet can be used close to shore, so the cables needed to carry the electricity generated can be shorter to reduce cost, that it won't interfere with migrating animals as it's situated near the seabed, and that it could boost marine life if life forms such as algae, mussels, and corals grow on the converters. However, the wave carpet can lead to smaller waves near the shore because it takes energy from them, leading to less mixing of nutrients, which has a detrimental effect on marine life. Marine life could also get entangled in the cables, even though the original paper claimed this was not a worry. And finally, the generators will make noise, possibly interfering with the communication of marine life, which largely happens through sound. In conclusion, the wave carpet does appear to be a viable form of harnessing wave energy, but the disadvantages need to be researched more to ensure it doesn't pose a danger to marine life, as many existing wave energy systems do. And that's it.